flare stars. In a star, there are some gases, and they're getting hotter because it is pressing together through its own gravitational constriction, because it's pressing onto itself, it's falling onto itself. It gets hotter. And when it gets a bit hot, then they're ionizing. And they're becoming plasma, these gases. They are losing an electron. They shatter apart. It's hot, but they shatter apart. Normally, atoms are neutral. They have the same amount of protons as electrons on the shells. They are neutral. Now they lost an electron. And now they have too much protons than electrons, so they are too positive. And they are no longer neutral, but they now a positive, negative charge technically. A positive charge, no. And such a star is circling. And whenever something is circling which has an electrical charge, which it has because it's not positive, that has a magnetic field. Every current has a magnetic field. That thing has no magnetic field, such a star, a T-Tauri star, a neutron star, or here flare stars. In flare stars, there accumulates this magnetic field, this force, this energy under the surface, typically near the sunspots. The sun has, but also these are in solar flares. So the energy is accumulating and then suddenly bursting out. All this magnetic energy is bursting out. And that has a lot of energy. It can be 6 septillion joules of energy. That is a very big number. Or 160 billion megatons. And it bursts then suddenly out. One of these stars is UQTTAPII. And if that thing has its flare episode, it gets 75 times as bright as usual. And it happens only in stars which are quite cool, so that it can accumulate. It's accumulating, they're not so hot, not so much radiating, they're quite cool, and then suddenly it bursts out. For example, Proxima Centauri, which is a red dwarf, so a bit slow burning star, and then suddenly it bursts out. And that is according to Mark A. Carnick's Cosmic Memory book on the page 50.